I'm delighted to accept this invitation to talk to you. Looks like a fantastic day that you've got planned to look at a variety of things. I interpreted the invitation to me as an opportunity to wax lyrical about the use of technology in supporting science learning. So what I've planned to do with you is to talk a little bit about current state of the Open University e-learning, and then take carte blanche from a range of technology enhanced science learning projects that either I've been involved in or I've been closely associated with. When I wax lyrical, I kind of sometimes overrun, so you may or may not get all the projects that I hope to talk to you about. And what I've done is I've focused very much on some externally funded research, which we hope is useful to the development of our practice at the Open University. I'm not going to talk too much directly about the current state of practical work in a third level course in geology. What I'm going to try to do for you is to give my perspective on the interesting trends in relation to technology enhanced learning that point us towards the future of this kind of work. Partly I'm going to do that because I need to ask you a question first of all. Is there anybody in the audience who has never had any contact with the Open University? Never enrolled in a programme, never done some part-time teaching, never worked for us, never met anybody who studied on a science course? Yeah, that's what I thought. So, I mean, in many ways I am preaching to, if not the converted, the very well informed. So it's not a surprise to you to know some of the details of the extent of the work that we've done in the Open University over the years. We've, since 1969, had many more than 1 million students studying with us. We do well in terms of review. We do well in terms of the opinion of our teaching. And in terms of what we have done in recent years, we have this notion of a supported open learning model, which I'll talk to you a little bit about. But some of the developments since in our 40-year history have involved a heavy use of technology. So we have this concept of open learning, might be into more and more it's learning with others, either in organised settings, in settings organised by technology. And we have, over the years, developed different ways of using resources to support that learning. And included in that would be the support from individuals, sometimes mediated by technology. So the original picture of the Open University as, which we also suffer from, I think the most embarrassing thing that you ever do at the Open University is retire from it, and people find pictures of the 1971 broadcast you made when quantum mechanics was all the rage and Kipper ties were in fashion. It's not what we do these days, as you know. We use a range of materials, we use a range of technologies, increasingly mobile technologies. And I mean, if I just put on the screen a sort of variety of the sorts of things that support learners in the university. We have open resource projects, we have an extensive connection with iTunes U, which I'll just check my figures. As far as I can tell, we're around about the 30 million download mark for some of our materials made available freely on iTunes U. And we have different media materials for 136 courses. And of those, you know, there's 110 ebooks available on OpenLearn platform for supporting this kind of work. So I have to say it's sometimes difficult even for Open University staff to negotiate this media-rich landscape. I have trouble finding my particular resources on iTunes U, but probably our students and people who wish to connect with the universities. I think what we're trying to do is use these platforms not only to support our own learners, but to make the world in general more aware of the work that we do. And I think for that, some of these platforms are very helpful. So talking about the world in general, over the last few years we had a very significant grant associated with the development of open educational resources from the William and Flora Hewlett Foundation. And on the back of that major development, we've also done some research on the use of these open learning network resources, a project I'm currently involved in, and I see Andrea in the audience too, recently with us at the OU doing research on this aspect. But I think my director, Josie Taylor, talked to this conference last year about the open educational resources aspect of that work. So I'm not going to dwell very heavily on that. I'm just going to single out an aspect of opening up our learning to the public, funded by the OPAL, or Open Air Laboratories Project Network, a development called iSpot. There's our Open Learn platform, lots of resources available there. And if you want more details about the Open Learn work and you weren't able to be at Josie Taylor's talk last year, I can give you some connections to what we're doing there. But what about this? This is the notcher moth. It's not been seen in this country very often. In fact, 2 years ago, a 6-year-old found, uploaded to a platform that we have, the information, I think with the help of her father, that she'd seen this moth and didn't know what it was. And the experts associated with this iSpot development got terribly excited because it hadn't been seen in Europe before. It could be that your daughter, as you can see there, has made an amazing discovery, really, it was. So what is iSpot? Well, it's a website jointly developed by the Educational Technology I work and the Science faculty. Main lead person in the Science faculty is Jonathan Silvertown, who conceived the idea of this work. And the idea behind iSpot is to involve everyone in work on science. It fits into a long tradition of work at the OU where using the national nature of the network, people associated with our work, even in 1971, we were asking students on the original Science Foundation course to collect Drosophila, to make measurements on SO2 pollution, and share those results together. In those days, how we collected the results from thousands of students together and made something of them was by post. They filled in forms, they sent in forms to me actually. It was my job to collect all this information and make some sense of it. And then we did a broadcast television program where we communicated things about how SO2 pollution, where exactly it was worst across the country. What iSpot does is allow a wider group of people with an interest in natural history to collect their own observations, share them in a community, and a community supported by experts. So what's this got to do with Open University teaching? Well, we were funded by a big lottery project to set up and develop this resource, but this resource now is used to support one of our short courses called Nature Neighbourhood, so that we're using this same technology to engage in collaborative discovery of issues important to science. And I think the reason that I'm excited about this work, apart from the obvious benefit it makes of Web 2 technologies, the fact that not just you can not just collect information, not just share it, but you can actually engage in collaborative discussion about it, is both interesting and a challenge for us. I mean, I think one of the things we did at the Open University in its inception was take a very rigorous approach to learning design. You know, working in these early course teams, activities were planned, timings were made, learning outcomes, though we didn't call it then, we called it aims and objectives, were specified. Etienne Wenger, he believes that learning isn't something you design, it's something that you design for so that you can facilitate it or frustrate it. Now, we all have examples of terribly clever projects that try to do interesting things that students then went off and did something else with. And this I take as my mantra. Not abdicating the responsibility for learning design, but looking at the possibilities of a learning situation and then watching to see what use students or other learners make of them. I think that was a remark about learning design. I want to make a remark about technology. I think you can get quite hung up, and I actually got slightly hung up when I saw the title I've given you for this talk. Usually what I do is talk about technology-enhanced learning. And that term carries lots of assumptions that automatically, if you use technology, it would always be for the good of a particular piece of learning. I worked with a research student called Jenny Waycott at the Open University a few years ago, and she was very interested in mobile technologies and took on board lots of work from Engstrom about activity theory. I think the thing I learned from her, who was my route into some of the work on technology mediation of learning, the thing I learned from her was that the introduction of technology into a learning situation changes it. You might think, and I think sometimes we're still guilty of that, of thinking what is in the education of a conventional science student. And we're distance educators, so we're not going to have the students all in the one place to put through laboratory work. So how can we use technology to make it all work properly, the way it should in a lab? I think the insight I get from the work of Engstrom and others is that when you introduce technology into a situation, the situation changes, the activity changes. Could be for the better, you hope it's for the better, and that's why I use technology enhanced learning when I can. But you have to be careful that you don't see the introduction of technology to a learning situation as something that's neutral. So a remark about that, I mean, first, when we introduced computers to distance learning, I think we were trying to mimic some of the topologies of learning. You know, your learners would be one place, you'd use a computer to communicate with them, somehow magically you would recreate the same situation. But I think these days we're more aware that, say, the introduction of technology-mediated learning changes the topology of the situation, so more possibility for group working. And I think that was a real key, important thing that happened in the OU in the late 80s, this notion of the use of technology to support group working, whether synchronous or asynchronous, but definitely using different locations. And I think the iSpot example I showed you, I would want to say, is an indication of how the introduction of technology is changing the boundary between formal and informal learning. I mean, some of the design features in iSport, I think, are very influenced by the kinds of technologies that people are using either in their social or everyday life. And I think it's very important for us in our quest for the design of good experience for our students not to ignore the interaction between learning that you think is happening because you've designed for it and it's part of a formal accredited situation, or informal learning. You know, I think we all learn by a mixture of the two. And I think the final change in topology, I would say, enabled by a technological development, because I wouldn't say, I have to say, I wouldn't say I'm not a technological determinist. I do think there are things that happen because of developments in technology. I think we sometimes slightly overstate the pedagogical control we have on changes to the learning landscape. Some of the changes to the learning landscape do happen because of the invention of technologies. Doesn't mean we don't have to make them work better, but I think some of the things we do are because of what is now possible with technology. And I think one of the key things for me that's interesting at the moment is the use of mobile learning. I mean, the learner is going to be moving between locations. I came on a train from Milton Keynes today, and the thing that, you know, if you can get a seat, you find people are using time in the time-honoured fashion. Open university students have always read course units on a train, but if you look round you, as you all have done in a railway carriage, the opportunities for learning and ways of accessing that learning have made a big difference to the topologies that we're working with. We've done quite a lot of work on mobile learning in my institute. Some connected to distance teaching, some more general, working with museums, working with specialists in healthcare. But I think we've seen the potential of mobile learning, and we currently have a couple of projects running that used mobile technology to support inquiry, and I'll tell you something a bit about this in the remainder of my talk. And I think these are interesting because of both the real and potential applications in the future to OU e-learning in the area of particularly field trips and accessibility. So I'll try and point these out to you. So the first project I want to highlight for you is one I've been involved myself in for the last few years, called Personal Inquiry. We've worked with the University of Nottingham on that. It's been funded by the Technology Enhanced Learning Programme, and my guess is that Richard Noss, in his keynote to you this afternoon, will probably tell you more in general about the programme. But we found this a wonderful opportunity to look at some of the issues in science education broadly, and to look at some of the ways that technology can support and enhance learning. Just a slight digression. I think we do have a bit of a situation in relation to the understanding of science. When I worked on the original Science Foundation course, we had this notion that we did want to train people really to be scientists, but we also wanted them to, you know, develop their scientific literacy. It was one of the aims and objectives in the original course to, I forget the exact wording, but to do something very similar to read with skepticism reports of science research in the media. And I've got some examples here of an example in the Telegraph. You see the headline, health warning, exercise makes you fat. The insert from Professor Blundell says, no, this wasn't actually what I said. Another familiar one to you from the Mail Online. This is relating to Susan Greenfield's views about dangers inherent in young children's use of technology. It doesn't make clear in the article that much of what she talks about, although she talks as a very eminent scientist of the brain, are to do with hypotheses about how things may be changing rather than peer-reviewed work. So what is a science educator to do in these circumstances? Well, what we took the money from the research councils to think about was how to develop in students, and we chose school students because we thought we might have some purchase to looking at a range of interdisciplinary science. So we focused on two different things. We focused on inquiry learning because there have been very interesting approaches over the years in looking at how science learning can be aided by inquiry. And we looked at ways of engaging students with science as a topic. Now, we took the idea of personal inquiry, and I think this works across the age range. What makes science engaging to people? Now, one of the approaches we've taken in the Open University is, well, if you show interesting programs of scientists doing practical things on, in rough science, you see the advantage of the scientific way of thinking. What we tried to do in this project was to link the kinds of education that in science that was happening in a number of schools to a connection with the students, either through connecting to themselves, as it says on the screen, or to issues around their community or their environment. So personal might be something that's important to you, or it might be something that you know about because it has local relevance. So what did we do? We're trying to help people think, talk and act like good scientists. We took 3 years on it. We took a fair amount of money. We wanted to develop the sorts of skills that students need to conduct inquiry, because the literature on inquiry learning is quite positive in terms of increased motivation, but there are lots of reported difficulties in terms of support for that kind of inquiry. What we saw as the potential of mobile technology was to take the inquiry learning outside the classroom and connect the learning that takes place in the classroom and at home and on field trips and in the playground together by using mobile technology as an enabling device. So we're not talking fancy mobile technology, by the way, but the teachers that we worked with were very, very keen that keyboards would be involved. So this was the lightest, most mobile thing we could find with a keyboard to allow you. And we worked quite carefully with the teachers to work out how we would support this kind of learning. I talked a little bit about motivation. What we did in the project was develop tools that allow data collection, discovery, visualization, analysis, but we also saw that the most important thing probably was some sort of measure of support for the inquiry process, and something we saw needed doing in relation to sequencing of activities. So a fairly kind of typical inquiry learning cycle that is a kind of reification of what's on many of the inquiry learning projects, starting from the notion of you find out what problem you really want to talk about, you do an inquiry question, you plan an investigation, which of course depends on the resources you have available, location, but also equipment, time. You conduct an investigation, you analyse evidence, you draw conclusions, you say what happened, and then you say how well you did it. It's all familiar to us, but it's not quite right, is it? That's not what it feels like when you do research. It's not what it feels like when you do inquiries. So what we saw as important to communicate through the use of our tools and sequencing in the software that we've developed called Inquire is to represent the way that sometimes when you get as far as deciding on your inquiry question, you kind of need to know what you've got available. So you probably are going to iterate back and forward. And even, you know, once you go on and analyse and represent your evidence, you discover that there are all sorts of outliers in terms of the data points you collected. So you're actually going to have to go back and at the very least check the evidence, but you might even have to go right back to the beginning. So this notion of phases and stages of inquiry is something that needs support. And the research evidence before us does say that all this stuff is really difficult, doing hypotheses, you know, so all the motivational benefits of doing inquiry in this way get drawn into question if you can't adequately support learning science in this way. So what we've done is a tool called Inquire. I won't go into too much of detail of it. I should explain. So we, in the navigation of the tool, used that diagram as a way. We communicated this diagram with teachers and children. We developed the language associated to talking about their inquiries. You know, orientation, no. Maybe find my focus. You know, we engaged students in whether there should be a cycle or maybe a spiral or whatever. So we did quite a lot of participatory design work. But we used that to incorporate into the sequencing. So how far did we get? 3 years and a lot of money. Gets you about 7 investigations across the range. Allowed us to develop, redevelop and polish the tool. I can tell you something about the particular examples if you're interested. But we now have an open source tool called Inquire, which is available for you to download from that address. It has some sample inquiries, but it has now offering tools that allow you to, you know, design your own inquiry. And as I said at the beginning, you know, introduction of technology to a setting does change what you're able to do. One of the examples, we worked on a geography inquiry on urban heat islands, where the introduction of the technology allowed its development from, you know, a 1-hour episode in the class, you know, in the classroom and playground to a 2-day yomp across Milton Keynes and Northampton, comparing the urban heat island features of 2 differently constructed towns. I can say more about that if you're interested. So what did we find? We did find that by using this tool, by developing this tool and working on the support of inquiry learning, big impact on motivation, measurable impact on cognitive outcomes, and the potential of the development of a community who are interested in taking inquiry learning forward, not just at school level. We've got a European network of people who are going to be working with us at different age ranges, so I can tell you a little bit more about that. No, at the end of my inquiry, how would I evaluate it? Well, knowing what we now know, you know, why didn't we have an iPhone? Why weren't we using the tool? Why were we developing tools? Well, we actually use sensors from another company called, but you can do so much with your iPhone these days. You can even, you know, have an anemometer. They do it, I think, by the sound of the wind across somewhere. So there's a lot. This is not an area that stands very still. We think our findings are in relation to how to support inquiry and how to support the development of hypotheses and the kind of evaluation. Very generic but very important science learning skills that we think we know a lot from having done the project. But, you know, with many projects, you do it differently if you started later or earlier. So we see great potential for mobile learning in formal and informal settings. I've given you a little bit of a flavour of how that works. The thing I haven't really talked to you about, you can see the potential for collaboration. The one thing that scientists do pretty much these days is not work on their own. We want authentic science experiences to be part of our distance learning. We have to be, at the very least, mimicking some of the processes that scientists would be doing engaged in, research teams. And that does lead me on to my next point, because one of the things you know about the Open University is that we need to enable remote access to some of our experiences. Okay, there are residential schools, okay. We've had some success in using simulations. And in the past, in the fairly recent past, we led a European Council-funded project looking at how you could get real remote science into the hands of learners. This was a multi-university project involving labs in Portugal and Ireland, and on that range of topics here. The thing we did at the Open University in that project is we took some of the experiences in our residential school at the foundation level, and we actually, mocked up a spectrometer and changed, as I've said to you already, using technology changed exactly what the activity was in ways that we can talk about. But we actually allowed students to make measurements, see things through a telescope, make real measurements on real equipment. This remote access to real experiments had quite a lot of potential, and over the years since there have been an increasing number, but it's not a cheap thing to do if you ever fancy going down that route. In terms of how this influenced work in the university, this is a better picture, I should have showed you this first. You'll see that you can see through a spectrometer, you can see the lab that you're working with, and you can even look at the Vernier scale and make measurements. Now, why is it worth trying to do that? Well, it's worth trying to do it for lots of reasons. One of the reasons is that if you've done this, the next time you come near a spectrometer, you actually know everything about how to set it and how to fix it. Some of the adjustments that we had to make, because the project was aimed at, to support students with disabilities, some of the things that we learned about what the controls should look like, improved usability for everyone, not just students with disabilities. But where did that kind of work go within the university? Well, one of the impulse behind it, enabling remote geology fieldwork, that was taken up in the ERA project run by some people in KMI, Trevor Collins and Mark Gabbard, with collaborators from the science faculty. And they, a few years later, thought, well, that's all very well, trying to extend access to lab work, but how would we extend access to practical field work with students with disabilities? And they, did transient networks. They worked with a third-level geology course team to try to find ways that, and here's an example of one of the sites, where a student with limited mobility, not able to yomp up the mountains and see at close hand, but able to use remote tools in communication with a tutor and other people on the field trip, get some support for feeling connected to the learning that they could do from practical work. Here's just a few more images to show you that it's wet and miserable on field work. That's why I gave up geology after 2 years. But maybe I wouldn't nowadays. Maybe I could sit in the Land Rover and direct operations from a distance. Students who were involved in this particular trial, yeah, they really wanted something like hands-on. Maybe not hands-on, but it's pretty good. And that project led directly into another Research Council funded project, which is a collaboration between IT, people in computing at the OU, Yvonne Rogers, people in the science faculty, Sarah Davison, Steve Lundby, and various industrial sponsors, where they sort of pushed this to the limit. They said, well, you know, how exactly would you set something like this up to make the most of the collaboration between people out there on the hillside and in here directing operation? They used some fairly snazzy technology, and those are the questions they asked. And this is an example of out there and in here. We've run some trials. You can get different sorts of collaborative learning experiences by using the technology in this way. Out on the hillside, you could see things, you could view images, you could write atlases and have audio conversations with students in the control room working at a distance to be completely connected into the activities. You can see screens connected to other resources that they had available, and also direct communication with people in the field. I think the thing that we found in relation to that, it's quite a big project and there are lots of different things to say, but talking to Tim Coughlin yesterday, I think the key thing that he feels is the nature, the strengthening of the practical activity by the combination of a remote team. Yeah, I talked to you about the inquiry learning cycle, and you can get lost in that cycle and think if you complete it you've got somewhere. The thing that they noticed, and I'm not sure that they predicted it before, was that the group at a distance did not feel left out. The group at a distance could actually survey what was happening and prevent people in the field getting too sucked in along the line of a particular hypothesis that was driven by the piece of rock they had in front of them. So they have an interesting perspective and have written up some papers now on the kind of metacognitive activity being supported by, you know, what essentially was an experiment to look at, you know, practically, does this work? Would it help students with mobility difficulties to be in these kind of command centres? Now, we're not about to send a table talk to every home student of science, but what can we learn about how these kind of activities, what it is that they really deliver for students, and what it is that can be unpacked from the experience of working in this way that we can use and incorporate in our day-to-day teaching and distance learning. And I think this is kind of back to the future really for me, because when we started out at the Open University, the view was, you don't do this sort of stuff, you know, this is not going to work. Your big challenge in teaching science is appropriate practical activity, and the inspirational people who were around at the start of the Open University Science faculty took the research head on. They didn't accept that everything that was in vogue in university science departments was necessary. They looked at the contemporary research about learning for practical work and really did a very thorough analysis of what needed to be abstracted from that work to inform our work in the future. And what I've tried to do for you this morning is not talk about solutions or predict the future of how science learning will develop at the OU, but just trying to read some of the runes that come out of quite influential research work on science learning that I think we will incorporate into future planning in the OU. So that was one of my conclusions. But my real conclusion is that we know that e-learning transforms the learning experience. We see the influence of the blurring between formal and informal learning settings, not just at the Open University, not just at places where distance learning. Of course, we see that throughout the education sector, and I think we are now seeing a kind of blurring between the idea of tools designed to support particular pieces of learning and the notion of how communities can be supported by technology to allow interesting learning to take place. I think this is a hard job, actually, to take on board all the changes in technology and the changes that we need to consider in terms of future learning experiences. And I think there are real challenges to educational institutions from these new topologies that I've been describing to you. So I can't finish without an acknowledgement of the many people who have given us money to do things. So it's really important that technology-enhanced learning is supported in this way, and Richard Noss will give you a real plug for that, I suspect, this afternoon, but also individual people who've supported different parts of that presentation, current and former colleagues whose work I have represented in my own fashion, but with their support. So thank you very much.